Welcome you to today's webinar. So we're here to introduce our new KiBox2, which is the next generation in propulsion measurement from Kistler. My name is Sam Oleski. I've been an engine application specialist with Kistler for over 11 years now, and mainly focusing on combustion applications. So I'm particularly excited to show off our latest solution for these very challenging measurements, and also talk about some new measurement capabilities that we're adding. I'm joined today by my colleague Janko Meyer. He's our KiBox product manager all the way from our headquarters in Switzerland, and he'll be helping with some of the presentation today. We certainly appreciate him staying a little late at work, so I suppose it's not morning for him. So we'll get rolling here. Hopefully everyone can see the presentation. So just a brief overview of what we're going to discuss. We're currently in the introduction, and we're going to introduce the new KiBox, look at the features and hardware in a little more depth, and then finally, Janko will talk about some of the new electric powertrain analysis capability that's coming to the system. Just some general housekeeping rules. I think everyone is going to be muted for the entire webinar. So for questions, please use the chat function or the Q&A function to send in your questions. They're part of the WebEx interface there. The presentation may not leave us much time to answer questions at the end, but we will absolutely be collecting those and getting back to people individually if we don't have time to get to those questions. So please submit any questions. We'll be the only ones able to see them, and we can certainly get back to you later very easily. So thank you. So to start, KiBox2, why the new KiBox? So the old KiBox, for those of you that are familiar with it, it's been a great combustion analysis system for over a decade now, and we've seen its use cases stretch from just basic combustion analysis, simple Pmax IMEP measurements, all the way to very complex custom formulas and research-oriented tasks. But like the industry is changing right now, we've seen the need for a comprehensive solution where combustion is really now just one piece of the entire powertrain analysis puzzle. So we really wanted to move from offering a combustion analyzer to an industry-leading comprehensive powertrain analyzer diagnostics solution. So we wanted to develop this future-proof, efficient, and multi-domain, highly capable platform for all powertrain engineers, not just combustion engineers. And that involves starting with very future-proof and sustainable hardware. We wanted to use the latest generation software and hardware, allow us to continuously develop the system. We also wanted to provide a very high level of value in the system, to provide a single platform that could be used for multiple tasks and make it easy to transition to the system, easy to work with the data. And we want to provide a turnkey solution from a single source. So again, making something that's easy to set up, doesn't require too much additional support or work to get going. So we started from scratch to develop a new kind of clean slate design for this KiBox. We wanted a very high performance data acquisition platform that we could then adapt for today's combustion and e-power requirements and other industry requirements as things change in the future. So we designed it from the core to merge those different technologies. Of course, it has the Kistler reliability and precision that everyone expects, and a brand new state-of-the-art user interface that we worked very hard on. Again, ease of use with the KiBox has always been a key cornerstone of the system, trying to make it as simple as possible to work with, even though it's a very powerful tool. So we really tried to make it intuitive to work with, the physical design of the system, and the software as well, to really make it easy to learn and easy to use on a regular basis. And then, of course, having it robust, compact, and able to manage really large quantities of data that are becoming increasingly common. So with that, I'd just like to show you a really quick demo of how the system works here. And to do that, as mentioned, the ease of use is really, really critical for us. So I'm going to do a quick demo of the system. Hopefully you can still see my screen. And I'm just going to jump out of the presentation, and I'm going to show you in 3 clicks, we're going to measure data from the KiBox. And then in an additional couple of clicks, we're going to be analyzing that data. So I'm right now just in my PowerPoint presentation. I'm going to jump over and launch the KiBox cockpit software. There's my first click. And then now that we're in the KiBox cockpit software, you can see I've connected to my KiBox. It's plugged into my gigabit Ethernet connection on my computer. And it's sitting next to me on my desk here, connected to an engine simulator. That's why it's not very noisy in the background. So you can see I've immediately connected. I have the history of the different KiBoxes I've connected to in the past. This one looks kind of dangerous, but it's just our demo system over in Switzerland. I'm going to use my second click now to open my parameter file that I last used. And you can see here, it loads the setup area with the engine data. And my third click, I will start our measurement and start collecting data. And so the KiBox switches from the setup mode to the measurement state. And you can see with that third click, we're taking cylinder pressure data from, in this case, 3 cylinders, looking at injection data. This is a diesel engine that's being simulated, our PV diagram, and then a nice strip chart with our indicated torque and engine speed plotted. And then if I want to, I can say, let's record some data. So I'll click the recorder button. Maybe I want to take a quick snapshot of data. And then with the fourth click after recording those data files, I now can switch to my data review mode. So it downloads the data from the KiBox. And now, just like that, I can select my recording and scroll through individual cycles. Or in this case, look at them in the time domain. And then that little snapshot of data I also took, which is only 3 cycles long, I can also scroll through that. So really, really quick and easy to get set up, much like the old system, but again, with our new interface. That. Going to jump back to our presentation. So features and highlights of the new system. The new system is a single system that really consists of 2 pillars. We have the cockpit software and then the KiBox itself. The software, which you just saw me running, is designed to be used online, meaning connected to the KiBox, or offline in a standalone mode. And that is the tool for parameterization, meaning creating your setup files, configuring the KiBox. It's used for visualization, which we just did, where we could see the data in real time. And then it's also used for analysis, which we also just did very quickly, which is to scroll through and look at and analyze data that we've collected. It also provides a data management tool for handling the quantities of data that the KiBox produces, and it handles the communications to third-party applications like your calibration environment or your testbed system. Then there's the KiBox itself. This can be used in a controlled mode, meaning it's controlled by the cockpit software, or it can be used in standalone operation where it's triggered by various signals to record data. It handles the signal conditioning of the channels, and it performs all the calculations on those signals in real time on the unit. So those calculations aren't being performed in Windows on the cockpit software. And then, of course, it handles the actual data acquisition to memory. So these 2 systems work as a team. They have individual tasks that each component does, but they are designed to work together seamlessly. So as mentioned, ease of use, really key. I keep mentioning this a lot, but it is important to us. So we really think really significantly about the different phases of the measurement, about the workflow that goes into using the system. So we really broke it down into 3 steps, the 3 different steps of taking a measurement, where you prepare the measurement, identify your objectives, and define the actual settings. That's the setup mode. Then we actually execute the measurement. So you record data, observe the signals, and then evaluation where you check your data and review it. So that translates to this active user guidance in the KiBox. You saw that single button I was using at the bottom of the screen, and that single button takes me between the setup mode, the measurement mode where I could view the data, and then the review mode where I can review data files that I've collected. And it's really just one button operation, this state machine concept that really keeps you focused and keeps you oriented on which task you're working on. One of the other things we wanted to do with this system was, again, trying to make a future-proof system. We wanted to really maximize the performance and the processing capability. So one of the ways we can test this and evaluate this is a really challenging use case, which is closed-loop combustion control. So in this instance, we wanted to look at taking data from an engine using the KiBox, making a calculation based on that data, and then feeding that calculation to the engine controller to then make adjustments to the engine control strategy based on that combustion data. Obviously, for this to work, you have to, ideally, you want to be able to make a change for the next cycle of the engine, or even possibly within that same cycle. So we devised sort of a worst case scenario test running at 20,000 RPM. So really very little time between engine cycles at this high of an engine speed. And then we pushed the system to its limit with 16 channels, just running an IMEP and peak pressure calculation. And in this situation, we noticed only a 300 microsecond delay time from the calculation start until the data was output or updated on the CAN bus. So in this particular example, at that really high engine speed, that only corresponds to 30 crank angle degrees. So that really does give the ECU a lot of time to make its decision. So we were able to verify a really high level of performance. Even if you're not using the system for closed loop control, you can be guaranteed that any data you're getting out of it, any data streamed on the CAN bus is available with a really minimal delays. So we also leveraged some modern designs and modern technologies when developing the system. We worked hard to design the user interface with Windows 10 support for touchscreens. So you can use a touchscreen device in a vehicle, for instance, during setup or during use. It really makes it a lot easier than having to navigate with a trackpad or a touchpad. The other aspect that's changed is obviously it's easier to get wireless devices. So we have a wireless connection available in the KiBox, and we're really able to leverage the fact that this new KiBox has a lot more storage inside it. So we don't necessarily need that super fast gigabit connection to reliably record and transfer data. We can now record data to the internal memory and then maybe use a lower speed connection like Wi-Fi to then transfer the data. I briefly mentioned in the demo, I had actually connected to a KiBox over in Switzerland. It was our demo unit. I was doing this through the internet, through our company's VPN network. It's not technically a supported way of communicating with the KiBox, but was always really impressed that I was able to remotely control and record data to my PC across the internet as though the KiBox was sitting right next to me. So it's a really robust, reliable system, and then this new wireless connection allows you to really move around a vehicle, for instance, and not be tethered to the box when you're setting up. The other big thing that's changed over time, I'm sure everyone's aware of, is if you've taken this sort of data, you can really see the data gets out of control quickly. These systems can produce really incredible file sizes and really incredible amounts of data over the course of one test. You know, it's a simple button click, and you've just filled up a few hundred megabytes of engine data. So we have a new data management solution built into the software that allows us to intelligently synchronize the data between the KiBox and our cockpit software on the PC. So you end up with one interface that shows you all of your measurements. The system synchronizes the data in the background. So if you're in the middle of a measurement and all the bandwidth is being used to display the data on your screen, it's not going to be sending data files in the background until maybe you've taken a break from measuring or recording that data. And then when you get back after your test, or when you're done running your test in the test cell, all that data will synchronize over to your PC and will be available for you to easily sort through and identify the individual files. So really helps make sense of some of the large quantities of data that you might be recording. The other thing that helps with data management a lot is this new recording manager. You may have seen it briefly in my very quick demo, but basically it allows you to visualize all the individual recordings that are taken during a measurement. And just to clarify what I mean when I say recording versus measuring, a measurement is when we just are viewing data, the KiBox is running, recording, or is visualizing signals, it's acquiring that data and translating them into usable signals for us. It could be streaming that data to another system or on the CAN bus, but it's not actually saving data to its hard drive. Recording is triggered by some sort of action, by a button press, by a signal, something of that sort. And recording is when you're physically saving that data to memory for review later. And so this record manager lets you visualize all the recordings that you've taken, either these longer duration records or these individual snapshots. And you can easily sort through them, remember, oh, I was taking data here and I think that was a junk file, I didn't need that. Or this event was really important, I had something exciting occurred and I really want to hone in on that signal. So it makes it easier to sort through all those files that you may have taken over the course of a measurement, either looking at them in the time domain or from a engine cycle number basis. So the new KiBox offers a ton of flexibility when it comes to capturing and recording data files themselves. So like most systems out there, we have this capture or snapshot function where we say you can effectively capture a moment, either a set amount of time or a set number of engine cycles you get to pick. And of course, we can record a certain amount of pre-data or post-data using the buffer in the KiBox. But it's based on a trigger and it records, again, if you say I want to record 1,000 cycles or 20,000 cycles or 100 seconds of data, that would be a snapshot capture. And then what's new is we have this record function where it's recording a period of time. And this is really more indefinite in terms of how long the duration is. So you could have this aligned with emissions data collection or some test, some trip around a test track, for instance. And so the stop time is not necessarily going to be clearly defined, but it's triggered by a signal or a button press or something that causes the data to stop. And then of course, all that data gets stored into an MDF format. What's also new, like the old KiBox, we provide audio feedback to try to make it easier to work with the system, to use the system, especially in a vehicle. To have that feedback is really helpful, to have that assurance that data was recorded or you started your measurement and you don't have to take your eyes off the road. What's new is we can now support voice commands. It's not really supporting hey KiBox or the Siri function like the logo implies, but I think we use the Windows functions built in to allow us to provide voice commands to the KiBox and to trigger different actions. So that again really takes it a step further to allow you to not have to stare at a screen while you're operating a vehicle if you are using this in vehicle. Another new function is the GPS position tracking. So like everything, we now have a GPS chip inside the KiBox. Kistler will not be tracking you, but the KiBox is able to record your position data. So this, so you probably have lots of other GPS devices if you are doing in-vehicle test. However, this is really helpful to have it all in one system if you're trying to say, oh, I remember I was on this stretch of highway when this weird event occurred. Let me go back and find the file I took at this location, things like that. It's really useful to know where you were. If you're in a test cell, I don't think you're going to use this too much. The other thing new but similar to the previous generation KiBox is this ability to interface directly to a crank position signal. And so standard trigger wheels like a 58X trigger wheel or a 36-1 trigger wheel and a regular Hall effect or VR sensor that might be on the engine, we can take that signal that's relatively low resolution and interpolate it to a very, very high resolution, as high as 0.025 crank angle degrees. So similar to the old KiBox, really being able to reliably and accurately take low resolution crank data and turn it into very high resolution crank angle data that we can use for combustion analysis. Of course, we can use an optical encoder, but this type of system is proven to be really, really convenient, especially in the vehicle. And this new device is very robust, can easily live under the hood, and then we isolate the signal and then transmit it back to the KiBox. So this really helps avoid interference and keeps the ECU happy from having a noisy crank signal. We have a number of file formats. If we compare to the old KiBox, we primarily were working with this .open format. With the new KiBox, we use a new industry standard MDF4 format that's widely supported by various data analysis tools and packages. We have similar formats for the parameter files, user formula files, and then of course CAN description files for bringing in CAN data as well. And then we support other formats, conversion to iFile, A2L files for our XCP interface, and we have all these different communication protocols that we still support. The API, which would be for directly interfacing with the KiBox software, our DCOM or serial testbed driver for interfacing with testbed automation systems, and our XCP driver, which is primarily used for interfacing with calibration environments, but could also be used for testbed automation integration. So I briefly mentioned it before, but one of the new features as well is CAN support. The old system had the ability to stream out CAN data. The new system has a much more flexible CAN bus configuration. We have 2 CAN ports on the unit, and both can be configured for transmission or receiving CAN messages. So you can use this system as your CAN bus monitor if you needed to. You can also utilize CAN signals as with other signals inside the KiBox. So for instance, if you had an intake pressure sensor available on the CAN bus, you could then peg your cylinder pressure data using that intake signal from a CAN message. So it doesn't require a separate analog channel to bring that signal in. And then as before, we can stream out all sorts of any calculation the KiBox can make should be able to be streamed on the CAN bus for in acquiring that data in other systems. As you may have briefly seen during the demo too, we have a brand new user interface, but as before, we really designed it with a clean, easy to use and very clear workflow in mind. So we have this main menu on the left that is generally always showing the same messages. That takes you down from the parameter settings through the signals, data processing, data storage, and then the visualization for viewing the data in the online and analysis modes. And then we have this dynamic toolbar on the right that really updates to show you relevant information depending on which screen you're on. And then at the bottom, we have a navigation bar, as mentioned, that state machine function that really takes you through the different tasks in the KiBox, from setup to measurement to analysis, and then back to setup. So we'll quickly run through a hardware overview for the KiBox and discuss some of those features. We haven't looked at the hardware in too much detail, but as you can see, this is it in all its high resolution glory. So it looks a bit different if you're familiar with the older KiBox. It's quite a bit more compact. It's less than half the height of the old KiBox, but much more dense in terms of the inner I/O. So a lot more channel capability and more going on with the unit. So you can see on the front, we have in this particular image, the full 16 channels integrated into the unit of different signal conditioning modules. On the back side, we have all the standard I/O interfaces that come with the unit. So the wireless networking, the Ethernet port for connection to the unit, the 2 CAN ports that I mentioned, and then the 3 different crank interfaces that I mentioned, 2 for optical encoders and 1 for bringing in the crank position sensor signal. Obviously the power inputs there, and then the digital I/O as well. Just a quick comparison to the previous generation KiBox. It's a bit lighter, a bit more compact. For me, the big highlights here are the power supply has a widened range available, so we can now go down as low as 6 volts DC, which helps keep the system running during cranking and engine starts. Sometimes eliminates the need for a separate measurement battery. You can just run this off the vehicle battery. The other big change is the amount of memory inside the unit. So I mentioned it has the ability to acquire data directly to its own memory, and we can do that because we have about 100 times the memory storage of the old KiBox. So you're really not going to run out of space for recording data in this system. And also have a wider temp range, so really useful for hot test or cold test environments as well. The analog inputs, so what you may have seen is the system has new signal conditioning modules. We call them our AQ modules. So a VAQ would be our voltage acquisition module. And what's unique about these is they have both the signal conditioning and the analog to digital conversion all integrated into one module, which really allows us to improve the performance of the whole system, reduce noise. And you can see compared to the previous generation, we've doubled the acquisition rate. We're now at 2.5 megahertz per channel. We have a much wider voltage input range for this module. And we've also doubled our resolution from 16-bit to 18-bit. Same thing with our piezoelectric module. Again, we've really reduced the signal path, so the output of the charge amp is immediately connected on this circuit directly to the analog to digital converter. So we've really improved our drift and noise specifications significantly. And again, similar double resolution, and we can support much higher crank angle resolutions because of our higher acquisition rate as well. And then finally, we offer a piezoresistive module. This would be for connecting to our piezoresistive absolute sensors, usually the ones with digital compensation that would commonly be used for intake pressure, exhaust pressure, and maybe dynamic fuel rail pressure analysis as well. So you can bring those sensors directly into the typical scope of what the system would look like then is when we would spec one of these out is you have the base unit itself, which is basically a blank slate to fill with whatever modules you would need for your analysis. You can fit up to 16 in there, but we can configure it with however many of the different modules that we've currently developed and mix and match however many of each you might like. What's great is if your needs only require a couple channels to start, we can configure it that way, and it's really easy to just add additional modules as required down the road and pull them in and out or swap them around depending on the requirements of a particular test. So you can really dial in the exact data acquisition channels to your specific test needs. And then finally, the different software package that would go with the system. Currently, we have the combustion package, which also supports torsional and vibration analysis. We have an add-on for a special KID3 knock detection algorithm. And then coming soon, we'll have a software add-on for electric powertrain analysis, which Yanko will talk about shortly. Lastly, if any of you have used a KiBox before, this sounds like a minor thing, but the Pelican case is a huge lifesaver a lot of times. It just makes transporting the system really easy. And of course, the new system also comes with this nice Pelican case for easy transport. I can't tell you how many times I've just slapped a UPS label on this Pelican case and thrown the whole KiBox in the mail. And I have no concerns that it all arrive in one piece, even if the Pelican case looks a little beat up. So really convenient to have. There are some new optional accessories available with the system. So we have a new cascading set for running multiple KiBoxes together, a 19-inch rack mount kit, which is really nice if you're using this in a test cell. You can even run two of KiBoxes side by side in here, or run it in next to some SCP chassis. And then we have our new 2614B optical encoder, which we can actually directly connect to the KiBox and eliminate the need for a separate electronics unit. As I just briefly mentioned, we can cascade or run multiple KiBox systems in parallel. So that allows us to go from a maximum of 16 channels, and instead we can have up to 4 KiBoxes, giving us a maximum of 64 channels if you really do have extreme channel count requirements, but the systems basically all run as a single unit together. You end up with one parameter file and one measurement file in your result with one point of control, and you just have to connect the crank signal to a single box for that configuration, assuming you were using the engine package. And then the only additional accessory that's required is this special network switch, which we use this PTP time synchronization protocol. It's a network time synchronization protocol, kind of the like NTP, but on steroids. I believe it allows for nanosecond level or even sub-nanosecond level time synchronization, which is really critical when we're recording at the speeds we're working at. So with that, I'm going to pass this over to Jenko for some to go through our slides on the new coming soon electric power analysis package for the KiBox.
Yeah, thank you, Sam. I guess you can write. So, as mentioned by Sam, we have quite a flexible system, and the flexibility is not also on the hardware side, but also on the software side. And we are currently in the process of developing a specific software application package which allows the analysis of an electric powertrain. We want to measure, calculate, and analyze the relevant parameters of an electric propulsion unit, and these according to an IEEE standard. So all the signals, all the calculations are actually standardized, and obviously fundamental if you want to dive into EV or hybrid applications. This domain is not new for Kistler. We have actually a department within Kistler who is developing and also providing e-machine test benches, and they are heavily interested also in using the KiBox for their application. And this department is supporting us with the necessary domain expertise, helped us during the specification phase, but also now during implementation and validation of all these algorithms. Yeah, that's what we have internal, but we also did some external tests together with the University of Loughborough, just to make sure that the concept we have in mind is actually really addressing the needs of the customers and also the wider application. So then next slide. There are a lot of similarities to the combustion analysis, and which is the KiBox actually designed for, is that we have specific tasks which are done in vehicle and other tasks are done in a test bed environment. And the KiBox can fulfill both these applications. We have seen it's compatible with rack mounting for test bed environment, but also specifically designed for the mobile application in vehicle. The tasks usually which are done are a little bit different, while the focus in vehicle is more on the charging, discharging, more on the DC power flows. In a more controlled environment like the test stand, usually losses and efficiencies are analyzed, but both features are actually provided by the KiBox. During the development, some topics raised our attention. Actually, we quite fast identified that it's key to have an accurate cycle detection algorithm, because all these calculations, according to the standard, are based on a calculation window and an accurate cycle detection algorithm of your three-phase e-machine. This is one definitely important part. The other part, which is also already implemented in the KiBox, is the online calculation and having fast and proper calculators which are running online in the system during the measurement. This is something that is already done also in the combustion analysis. Then the accuracy of all the components is quite key. It doesn't make sense that we have high accurate calculators running in real time if the necessary signal front end sensors and signal conditioning parts are not fulfilling these accuracy requirements. So it's really the full chain which needs to be monitored closely and needs to be understood as well. And the last thing, the KiBox gives access to raw data for detailed analysis, either for recalculations or analysis after the measurement. This is in commercially available products not always the case, or almost never. And with the KiBox, who is capable of collecting and recording raw data in parallel to the results, we can provide this picture. When we look at the signals which we are going to measure, obviously it's a lot of currents and a lot of voltages at different points. So when we start from the left side, we have the full charging path to the battery as well, then the DC path from the battery to the inverter, and then the three-phase AC connection to the e-machine. But in the Kistler portfolio, we also have torque flanges and torque sensors, which then actually can also provide some information about the mechanical power which is provided by the e-machine. So we have the efficiency from the transformation from e-power to actual mechanical power. And not to forget is the temperature monitoring, quite an important topic in an e-powertrain. We also can record this information. When we look now at the calculators, next slide, then we have different calculators for the different signals, obviously. So I'm not going into the details, but we have specific calculators for these AC signals. We have calculators for the DC power analysis, the efficiencies, and also the mechanical power resulting out of the sensor. So we can combine all these different calculators. As I mentioned, they are standardized in IEEE standard, and we are calculating these according to this. So as mentioned by Sam, all these calculators and signal types and so on will be bundled in a new application package. It's called epowertrain analysis basic. So it's really the fundamentals which we are providing now in the first step. The release 2.0 is scheduled for the fourth quarter of this year, so quite soon. Developing is processing very well. We have promising results, and we are confident that this is then available at the last quarter of this year. So in the combination with combustion analysis, you have then the full capability of analyzing hybrid powertrains, but obviously you can also just use the combustion only for traditional combustion engine, or e-powertrain only if you have a single pure e-machine drive. And in a summary, next slide. So we really are capable of doing a lot of interesting things, which then allows you to result in some application we can address. So on the left side, as I mentioned, we do all the calculations. We have this raw data access and the accurate high-speed cycle detection algorithm. And all the data is obviously recorded synchronously. Doesn't matter what kind of sensors you attach to the system, if they are specifically for e-power or combustion or torque or NVH. The e-power analysis at start will support 1 or 3 phases and multiple e-machines. And we also have some new diagram types, obviously, to display the data. And the applications we have already talked about. It should really be, you should be able to analyze the full powertrain from the charge to the mechanical output power. So that's it from my side as a first teaser. Yeah, again, it should be available at the end of the year.
Thank you, Janko. I appreciate that summary and overview of the new package coming soon. I'm definitely excited to see that and learn more about it as it becomes available soon. So a quick summary while we are running out of time here. So really, the KiBox2 does provide a complete solution, all from Kistler, all from a single source. Everyone, I think, is familiar with us for our sensor technology. We have a very deep and rich history in that area, going back over 60 years with our combustion pressure sensors. Hard to believe it's been that long. And everything from measuring spark plugs to direct mount, water-cooled in-cylinder sensors, intake, exhaust, pressure, and really any pressure, force, or acceleration measurement we can support. All the way from the signal conditioning to be able to bring those specialized signals directly into a module and have them cleanly converted to a digital signal, all the way to the data acquisition and data storage inside the KiBox, the data visualization and analysis in the KiBox, and coming soon, not really talked about here, we will be leveraging our JBeam and also our MADAM software packages to really take a real step further in our ability to both analyze, post-process, and also manage really large quantities of various types of engine data or any sort of powertrain data, really. These are very powerful tools, and we're now working to adapt them for engine applications. So stay tuned for more on that. I'm looking forward to those solutions as well. And then, of course, our wide range of accessories from optical encoders, TDC probes, current clamps that could be used for injection or ignition timing. And then, of course, as mentioned, the full suite of compatibility with various third-party systems and solutions, whether it's your calibration environments, Inca or Vision or Canopy, and then also the different testbed protocols that we support with the KiBox to really allow you to use it with your, Puma, Stars, DCOM, really, or Morphe, any real testbed protocol or system out there should be able to support either receiving data from or sending commands to the KiBox. And then, of course, our XCP interface, which would be used for a lot of those interfaces. So really, just the key criteria for the KiBox: is it future-proof and sustainable? Yes, we really feel we've made a truly flexible, easily expandable solution. Uses latest generation hardware, and it's also a platform we are going to continuously develop and adapt to modern measurement challenges and solutions. As you see, we're working hard on the electrification area, which I think is going to be, to say it's important moving forward, maybe an understatement. And then we want to really, again, provide high value for money here. This should have an attractive initial investment, a really relatively easy learning curve for such a powerful system. We really do focus on trying to make this easy to work with and easy to use. And again, trying to give you a turnkey solution that, you get the entire package from us and connect it to your powertrain, your engine, your motor, and you are off and running. Messing with too many other systems or band-aids or things like that to get this to work. And then, of course, the support that we hope you think highly of from Kistler. So really, we feel it's the real answer or a real solution for future powertrain measurement tasks. So Q&A, there are some questions in there. I appreciate everyone's questions that they've added. I've unfortunately blown through our time by 2 minutes here. So what I think I'm going to do is save your questions here, and I will certainly be getting back to everyone individually if there's any questions. And I'm always happy to set up individual meetings. This has been a really bizarre year. I wish I could say this was the first WebEx I've done in a long time, but we've all gotten really good at these web meetings. But I really look forward to hopefully interfacing directly with anyone that's interested, and maybe even coming on site and seeing you in person with a real KiBox. So that all sounds good to me. So certainly reach out if you have any additional questions. Anyone that's asked questions, I'll be getting back to you. I want to thank Janko for his time today, and Mike Tokar as well for helping me set up this webinar. He's many of you may know him as well. So yeah, I appreciate everyone's time, and hope you all have a good rest of your day. Thanks for attending.